All right, so we're going to talk about just even and odd roots. So we saw that when we talked about square roots, that if I had the square root of a squared, that was the absolute value of a that we got back. And like I said, and the reason that works is because when we have squared roots have a principal root and a negative root. So what we see when we look at anything that is an even root, if we have an even root, so we're going to say, oops, not a big enough n is going to be even. So if I do n and I do a root of anything, so let's say a to the n, what's going to happen is the same thing that happens with square roots, is that we have a principal root and a negative root. Because if I had, say, -2 to the power of 4, well, that's going to give me positive 16 because I have an even amount of negatives and they cancel each other out. But 2 to the power 4 is also going to be 16. So if I'm looking for a fourth root of 16, technically there are two roots. You technically have the positive and the negative root, but we're only going to look at principal roots. So any case where we have two roots, we're just taking the principal root, the positive root. So once again, when we look at a problem like this, if I did the fourth root of -2 to the power of 4, we know that's going to turn into positive 16, so then I would get 2 back. And this works with any kind of even power. You're going to see that same thing happen over and over and over again. So if I do the nth root of a to the n and n is even, then what I want to do is make sure that I keep the principal root. Which gets me right here. If k is an even natural number, then for any real number a, the kth root of a to the k is absolute value of a. And then when we were looking at cube roots only have one root. So if I did the cube root of a cubed, well, that was just going to be a. So the same thing kind of applies. If I do -2 to the power of 5, that is going to give me -32. 2 to the power of 5 is 32. So if I did the fifth root of -35, I get -2 back. And if I do the fifth root of positive 32, I get positive 2 back. So we only have to worry about one root. So whatever a is what's going to come back out in the end. So this means if I have an odd root, and is going to be odd now, then it doesn't matter that we don't have to be concerned about a positive negative root. We just have to be concerned with what is the root. Which gets me here. If k is an odd natural number, then for any real number a, the kth root of a to the k is just a. So we only have to worry about that absolute value part if we're looking at even roots. If we don't have even roots, then it's not a concern for us. Okay, so just as an example here, we want to figure out what is the fifth root of 247. So if I get out my calculator and we look at our fives, 1 to the power of 5, well, that's 1. 2 to the power of 5, that's 32. 3 to the power of 5, well, that is 243. So that is what I needed right there. So I know the fifth root of 243 would have to be just 3. Now, in the case of 5, and we're doing the root of -243, remember this is an odd root. So that means that I can get -3 back. So just like with square roots, if I had square roots, our cube roots, the cube root of 27 is going to be 3. The cube root of negative 27 is negative 3. So it's the same idea here. If I do the 11th root of m to the 11th, it just comes back m, because once again, that is an odd root. Now, if I have even roots, so I took the 4th root of 81, 1 to the 4th is going to be 1. 2 to the 4th is 16. 3 to the 4th is going to be 81. The 4th root of 81 is just 3. Now, the 4th root of negative 81, so we know that 3 to the power 4 is 81. Well, what about negative 3 to the power 4? Well, that's positive 81. So just like with square roots, I can't do the square root of a negative number. I can't do the root of any number if my root is even. So this is undefined in real numbers. And like I said, and it has to just do with that property of an even root. So even roots are going to act like square roots. Odd roots have the same things going on with them as cube roots. If I do the 4th root of 16m to the 4th, well, that is 4th root of 16 times the 4th root of m to the 4th. Well, we see here that the 4th root of 16 is just 2. And the 4th root of m to the 4th would be absolute value of m. So once again, take a minute and pause. So you have some even roots and you have some odd roots. And just for fun, let's add one more in here. Let's just take a minute and, like I said, this will be our D here, just to add one more even root. Go through and look, like what's that, assess if it's an even root and an odd root, what properties apply, and then what is my answer going to be. Okay, so everything here is basically powers of 2. So I just put them along the side here. So the 4th root of 16, well, there's 16. So 2 to the 4th power is 16. So the 4th root of 16 is 2. The 5th root of negative 32, well, this is positive 32. Well, here's negative 32. So that came from negative 2. Then for C, this is a odd root. So we're doing the odd root of something that is raised to an odd, to the same odd power. So the 7th root of 5 minus x to the power 7. Well, that's just going to be 5 minus x. If we have an even root, like we have here, then what's going to happen? Oops, that was all to the power of 8. I didn't quite get that in there when I wrote it. So I have the 8th root of 2x minus 7 to the power of 8. That is just going to be 2x minus 7, absolute value.